Hello everybody, my name is Philip, and in this video I'll be showcasing an artificial intelligence algorithm as part of my university project. I have chosen the evolutionary algorithm specifically for this project due to its relative simplicity and good suitability for my application, where, as part of the project, I was asked to firstly create a game and then create an AI that would play said game. After seeing clips of people trying to overcome ridiculously difficult levels in games like The Impossible Game,
Oh, it physically hurts! I'm in misery! I'm in agony! Why can't I get through the same? Oh, I am just want to get through. I think I'm crying. I think I'm crying, guys. I think I'm literally crying. I don't want to do it anymore. I don't want to play. Yes? No!
or a very similar title Geometry Dash.
Okay, it's this big! Fuck! Ah! God! Oh my god. Who the fuck made this game? Bunch of sadistic motherfuckers. I agree it's too easy. Let's crank up the difficulty to a fucking dick ton. Oh my god, this is the first I've made it. God damn it! Mother! Fucking God! 83%. I'm so close to finishing this bullshit. Okay. Got this.
I have eventually decided it might be a cool idea to try and do exactly that. Make a game like one of them, and then create an AI to play it. I've decided to use evolutionary algorithm, also called genetic algorithm. The whole subset of computing called evolutionary computation is a nature-inspired approach to problem solving and optimization, inspired by the idea of survival of the fittest or natural selection from Darwinian evolution. The idea behind the evolutionary computation is that if biological evolution can produce optimized and adapted results over many generations, then we should be able to recreate that process artificially to evolve optimal solutions for our problem. These days, this can be used in many fields such as engineering, biology, robotics, and the list goes on. The evolutionary algorithm. The way it works, it firstly creates a population that contains all the creatures which are going to be competing against each other and are generated randomly. Then, natural selection takes place in the form of a fitness function. Fitness determines the likelihood of survival for each individual creature, the higher the better, and also better chance of this creature reproducing, thus passing its genes onto the next generations. In our case, the fitness is based on the distance between the player and the end goal. A randomized mutation is also a big part of the process to potentially randomly enhance our creatures. And so after we evaluate the creatures' fitnesses, and mutate them, the most fit creatures pass down their genes onto the next generation, and we can create a new population of already stronger or fitter creatures. And as we repeat this process over time, the population will optimize itself to the best possible result. And so, the way I've done my implementation is, I've started with writing the AI first. Each creature, or player in my case, has an array of movement vectors called brain, that determines if and how they move around. Because of the nature of my chosen game, the only movement we really need to worry about is up, or jumping. As the players progress through the level, the one that gets the farthest, or closest to the goal to be more precise, is then declared champion. The champion is then copied exactly unchanged into the next generation, while the rest of the players undergo natural selection and mutation. With these rules implemented, they should be able to navigate almost any legal level, given enough time to learn. In the end, I've chosen Geometry Dash as my inspiration for the overall game and level design, as I'm a bit more familiar with that one over The Impossible Game. My goal was to recreate the very first level of the game as close to the original as I could, while not making it too difficult for my players. And it took a surprising amount of time for me to figure out the layout for the first level, as I wasn't able to find any documentation for the layout. And so I ended up playing through the level over and over and over again while building my game at the same time. As you can see, the first version of my players had severe trouble even getting through the first few obstacles, and so it took some optimization and a few generations for them to improve. Unfortunately, at the time of making this video, I'm starting to realize that I may have been a bit too ambitious with the length of the level, as the best result I've been able to observe was about 1/3 of the way into the level, and even that took them over 250 generations and about half hour. Increasing the population size would speed up the process significantly due to the random nature of this algorithm, but I'm afraid my poor little laptop would sooner explode than drop in a few more players. I'm certain that given enough time the players would be able to reach the end goal, however I wasn't able to test that. With algorithms like these, there's almost always a lot of room for optimization to make them more efficient, but even in this state they would be able to get there given enough generations, mutations and time. But anyway, thanks for watching.